Hello everyone, this is Dr. H.P. Akila Purnima. So I am from Department of Computer Science and Engineering, RIT. So in this video, I am going to discuss about the construction of SLR parsing table, right? So SLR parsing is a bottom-up parsing. So S stands for simple. So SLR is nothing but simple LR parsing, right? And the L stands for that is the input is scanned from left to right. That is the meaning for L. And R denotes that this parsing strategy uses bottom-up parsing. That is, it uses rightmost derivation, right, in reverse. That is R, S, L, R. Okay. So let us see this with an example. So the given grammar G is a very simple grammar. It contains only three productions. E implies E plus T, E implies T, then T implies ID. So this is a given grammar. So in order to construct an SLR parsing table, we need to a pre-processing thing. That is, first thing, I have to add an augmented production. Right? So augmented production is nothing but, let us see one by one. See, here G is the start symbol. So I need to add one production. E dash implies E. This is the augmented production. And the other productions you should write as it is. That is E implies E plus T or T. And T implies I. Right? So this is the augmented grammar G dash. So before proceeding, you need to write the augmented grammar for the given grammar. Augmented grammar is nothing but it will be containing one more production, that is augmented production. E dash implies, right? So, and here we are going to start producing LR of 0 items, right? So we are going to construct LR0 of items. So for constructing this LR0 of item, we should know one thing, that is, see, let us take a fresh page. Right? So write the augmented production. First augmented production, that is E dash implies E, right? So here before E, I have to place a dot, right? So the dot denotes that the symbols which are right to the dot have yet to be read, right? So these are the symbols which are right to the dot have not been read, right? And the symbols which are left to the dot, left to the point, has already been read. That is the meaning for dot. So in I naught, first I need to place the augmented grammar, augmented production. E dash implies dot. Now analyze this production. So this production, that is the immediate right symbol of dot is E, right? Immediate right to dot is capital E. This is a non-terminal. So if a non-terminal resides at the immediate right of dot, then you have to write or you have to add the productions of that non-terminal. So now the immediate right production, immediate right symbol to the dot is capital E. So I need to add the production for E. So E is dot E plus T and E implies dot T. Now see that, see in the newly we have written two new productions, right? E implies dot E plus T and E implies dot T. So let us see the first thing. See here, the right, immediate right symbol to dot is capital E. So you need to add the productions for E, but already we have added the productions for E. So leave it. And see the next production, E implies dot T. So the immediate right symbol to the dot is capital T. This is also a non-terminal. So you need to add the production for this terminal. So here T implies dot ID. Right? For T, we have only one production. So T implies dot ID. Now, I have created a new production, that is T implies dot ID. Now see the immediate right. So immediate right to the dot symbol is ID. ID is nothing but a terminal. So there is no need to write any more production. So you can stop here. So this set of items is I naught. right? Now, observe this set of items I naught, right? See, the first item, first production is E dash implies E, right? So here, so listen carefully. Here in the first production, dot is here, right? So immediate right is capital E. So you can give capital E as input to this string. If you give capital E as input, what will happen? The dot will move one symbol ahead, right? So one symbol ahead. So if I give input E to this item, what will happen? E dash implies E dot. Right? So this dot moves one symbol ahead. So E dash implies E dot. And next production, so after dot is capital E. If you give capital E as input, what will happen? E implies right? E implies E plus, sorry, dot plus T. Now the dot moves one symbol E ahead, right? E dot plus T. So this is what and use items, right? See here, observe this dot. So after the dot, there is no more symbol. And here after the dot, there is immediate right symbol is plus. This is terminal. So no need to write any more production. So this is I1, new set of production. Let it be I1, right? And so see the next production here dot. So after dot, capital T. So if I give T as input, what will happen? E implies T dot, right? And so after dot, there is no symbol, right? So leave as it is. So this is a newly created set of item. Let it be I2, right? And for this, see the next last production here, T implies dot ID. So if I give ID as input, what will happen? T implies ID dot, right? So after dot, there is no symbol, right? So this is the sorry. So this is nothing but I3, right? I3. Now, so for I naught, we have given all the possible inputs because after dot, three symbols are there, right? Capital E, capital T, ID. So all the inputs have been given and we have transited to three new states, I1, I2 and I3. Am I right? So now, so I naught has been completed. And just observe I1. So I1 consists of two productions. So see the first production, E dash implies E dot, right? So dot comes at the end. There are no more productions after dot. That is right to dot. So leave it. And the next production is E implies E dot plus T, right? So after dot, one symbol is there plus. So for I1, if I give input plus, what will happen? E implies E plus dot T, right? So now observe this dot. So after dot, one non-terminal is there. So I need to add the production for this new terminal, that is not terminal T. So T implies dot ID, right? So observe this newly created production. So after dot, terminal is there. So there is no need to add any more production. So complete this. And this is nothing but set I4. Name it as I4. So I1, I can give only plus as input. So I have given completed. And then observe the set I2. I2 has only one production. E implies T dot. So there are no more symbols after dot. So leave it. I2 has been completed. Then observe I3. So I3 consists of only one production. T implies ID dot. So it is also have been completed. It has also been completed. Leave it. Now we are having only one set of item in hand. That is I4. Right. So for this I4, what I should do, analyze it. So after dot, there are two symbols. One is capital T and another one is ID, right? So if I give T as input, what will happen? Sorry, E implies E plus T dot. Now after dot, there are no more symbols. So, so you can name it as I5. Now, what are the other possible input? ID. So if I give ID, what will happen? T implies ID dot. So T plus ID dot production is already there in I3, right? So if I give ID as input for the state I4, that is for the set of item I4, it will transit to I3. Okay, so everything has been completed. So now analyze all the set of items, right? So there are no more possibilities to give input, right? So this is what your automata for the given grammar, right? So I naught, I can give three possible inputs, capital E, capital T, and ID to transit to three new states, I1, I2, and I3. And for I1, I can give plus as input, so it will transit to I4. And for I4, there are two possible inputs, capital T and ID. If I give capital T, it will transit to I5. If I give ID, it will transit to I3. That's all. Right? Now, let us see. Okay, so we have how many productions in hand, how many states in hand? I naught, I1, I2, I3, I4, and I5. That is I0 to I5. So there are six states now, right? Now, from this automata, you have to formulate the SLR table, right? So the SLR table consists of two major parts. One is action part and another one is go-to part. So the action part consists of four categories of entries, right? The action part consists of four categories of input, entries. Let us see one by one. See, let us form the table now. So what are the states? I0 to I5. The name it is 0, 1, 2, 3, 4, and 5. There are six states, right? So for the six states, so I already told that there are two major parts. One is action part and another one is go-to part. Let it be, this is action part and this is go-to part, right? So the action part, deals with terminals alone. So what are the terminals present in our grammar? Plus and ID. These are the two terminals available in the given grammar, right? So let me to add this. This is plus ID. In addition to these terminals, I have to add dollar here, right? So in all the grammars, I'll be adding dollar in addition to the available terminals. So in the non-terminal, that is go-to part deals with only non-terminal. So what are the non-terminals available in the given grammar? That is capital E and capital T. See here, you should not include E dash because E dash is the augmented production, right? You have added. That is not given in your grammar. So you have to include the non-terminals which are available in the given grammar only, right? So here it is E and next one is T. That's it. Now let us concentrate on the action part. So I have already told that action part consists of four categories of entry, right? So what are they? Shift action, reduce action, then accept action. Another one is error. These are the four categories of entries in the action part. What are they? First one is shift, then reduce, and then accept. The last one is error, right? So error is the unfilled entries are all errors, right? Unfilled entries or errors. Okay. So when to shift and when to reduce, right? This is what we are going to fill here. Now, see, see, this left side 0, 1, 2, 3, 4, and 5 represents the states. I0, I1, I2, I3, I4, and I5. These are the states. So let us see the automata here. So for I0, if I give input as, see, what are the inputs? There are terminal inputs given to I0. Only ID is given, right? See, there are three possible inputs given to I0, capital E, capital T, and ID. Among this, only ID is the terminal, right? So here for zero, if I give ID as input, right? ID as input, what will happen? See here, for I0, right? If ID is input, what will happen? It will transit to a state I3. So here, you should give it as shift 3, S3. So the operation, that is the action performed as shift. Where I am going to shift? 3 states, that is state number 3, I3. See the automata clearly? So for I0, if I give ID as input, where it will go? I3, shift to 3, right? So for 0 ID, I'll be giving shift 3, S3, right? And so for 0, will I give plus as input? No, I will not give plus as input. And also dollar, I will not give dollar as input. Am I right? Okay, let us see, let us move to the I1 state. One state. So here I can give plus as input, right? This is a terminal. So for 1, that is the state 1, I1, if I give plus as input, what will happen? It will transit to a new state I4, right? So for 1, if I give plus as input, I am shifting to, where I am shifting? S4. So shifting to S4, right? I'm shifting to S4. Next. So for state I1, will I give any input ID and dollar? No, I won't give ID and dollar any input. So leave as it. Don't fill the in. And for the state 2, see the state 2, I2. So for I2, I won't give any inputs, right? In I2 consists of only one production. It has already been read, right? Completed, reduced form. So there are no more inputs for I2. So leave the I2 entries. That is the entry 2 as blank. Leave as it is. And for 3, I3. So for I3 also I won't give any input because I3 consists of only one production that also has been read, that is completed, reduced form. So I will not give any input for this I3. Okay, leave us. Next. So for 3 also there is no entry. And see the fourth state, I4. So I4, I'll be giving two inputs. One is small ID and capital T. ID is terminal, capital T is non-terminal. So here in action part, I'll take only terminals into consideration, right? So here ID. So for I4, that is state 4, if I give input ID, it will transit to I3. So I4, see I4, ID as input will transit to S3. Am I right? Yes, S3. Shifting to 3. Okay. Now, for I5, there are no more inputs. I won't give any inputs for I5. Okay. So, this is the action part. And one more thing. This is shift operation. There are four categories. One is shift, another one is reduce, right? So, for reduce, see, for reduce means I have to analyze the automata. Here, I1 consists of two, see the I1 state. So in I1 consists of two productions. One is E dash implies E dot, another one is E implies E dot plus T. See here, the first production is completed one, right? Completed one. And here the E dash is nothing but augmented grammar. So for the augmented grammar, what I should write? For I not as in, sorry. Okay, leave it first. first we won't take the start symbol, that is the augmented grammar, into consideration. Leave it. I'll tell you the at the last. See, what are the four productions given? There are four productions in the given grammar, right? This is the given grammar. So in the given grammar, let us number it. Okay. So this is the first production. E implies E plus C is the first production, and this is the second production, and this is third production. Okay, let I write. See, let us write it separately. E implies E plus T. This is production number 1. And E implies T. This is production number 2. And T implies ID. This is production number 3. Okay, so now look at the automata. The first production E implies E plus T. Right? So I have to find where this production gets completed or where this production got reduced. Right? See, in I1, no. I2, one production has been completed. That production is E implies T dot, right? Why I am saying that it is completed means the dot is at the end of the production, right? That is why I am telling that E implies T, the production has been in a reduced form, right? So E implies T dot. So E implies T. What's the production number? E implies T is the second production number 2. So now, so I have to fill. That is in I2, there is in I2, second production is reduced. R2. I'm just telling it as R2. That is second production. E implies T dot T. It's a second production. It is in a reduced form. So I can put it as R2. Right? And see I3. I3 also consists of only one production. That is also T implies ID dot. So T implies ID is the third production. Right? See this? T implies ID is the third production. So here the third production got reduced. So in I3, third production has been reduced, right? And see I4, there is no completed production. There is no reduced production. And see I5, so in I5, the first production got reduced, right? So E implies E plus T, that is R1, right? Now, I have to fill these entries in the action form. So where I need to fill R1, R2, and R3. Let us see. Now, what is R1? R1 is at I5, right? So, in I5, the first production got reduced. Now, so where I can fill this? For what's the production reduced here? E implies E plus T dot. Now, we need to find follow of, right? Follow of E set, right? Let us see. See, follow of. So see the given grammar. Follow of E is nothing but plus. Am I right? Follow of E is plus. Yes. Follow of E is plus. Follow of E is plus. And one more symbol I have to include here. That is dollar. Why? Because this capital E is a start symbol. In the given grammar G, capital E is a start symbol. So for the start symbol, you have to add dollar in the follow symbol. So follow of E is plus comma dollar. Now, so where I have to fill R1, right? Okay, I'm having R1, right? R1. So where I have to fill this R1. Now, this the status I5. So for I5, see I5, what is the follow of E? Plus and dollar. So in plus and dollar, I need to fill R1, R1. And next, so where I need to fill R2, so R2 has been reduced at the state I2, right? I2. So I2 line E like T dot. Now I need to find follow of E. So I already found follow of E. What is follow of E? Plus comma dollar. Now I have to fill in the second, that is in 2 comma plus and 2 comma dollar. I have to fill it as R2, right? And R3, where R3 is like R3, that is I3. In I3, the protection 3 has been reduced, right? So what is the protection? T implies ID, right? This is third protection. So we need to follow, we need to find follow of capital T, right? This is the protection, right? T. So follow of T I need to find. So what is follow of T? So follow of T is, so in the given grammar, what is follow of T? Follow of T is nothing but it's equal to follow of E. Follow of E. So what is follow of E? Follow of say plus comma dollar. Now, so where I have to fill R3 in I3, state I3, right? I3 in plus and dollar. Plus and dollar R3, 3, right? So in the augmented grammar, we have added one more protection. No, E dash implies E. So where it completes in I1, it got completed, right? It got reduced, I1. So for this protection, this augmented protection, we have to fill here, that is in one and dollar, we need to write accept. This accept. So as of now, we have filled three categories of actions in the action part. What are they? Shift, reduce, accept. So what are errors? All the unfilled entries are considered as error, right? All the unfilled entries are error. Now the action part got over. Now we have to fill go to part. This is very simple. So go to part is nothing but for the state, if I give the non-terminal input, where it will go. See, for I naught, if I give capital E as input, where it goes? I1. So I have to fill it as 1. So if I naught, if I give capital T, where it goes? I2. So here I have to fill it as 2. Then I1. So I1, I will not give any input, right? I1, I won't give any input. Sorry, I1, non-terminal input I won't give. Only terminal input I will be giving, right? And for I2, I won't give any input, right? Then for I3, I won't give any input. For I4, I will be giving two inputs. Among them, one is non-terminal, capital T. So I4, I'm giving T as input. So 4T. What will happen? It will transfer to I5. So 4, 4. So for 2 years, it goes to 5. And for I5, I won't give any input. Yes, that's it. So this is what your SLR parse table is. So the parse table consists of two major parts, action part, go to part. Action part, so it will be having the terminals, right? Terminal transition and go to non-terminal transition, right? So these are the steps to construct SLR parse table. I hope all can understand this concept, SLR construction, right? Thank you.